Sam. He's going to go over a lot of the architecture on Farcaster.
Basically, Farcaster itself has evolved quite a bit in terms of architecture. Like this diagram used to only be around this big initially, then it expanded. If you look at what it says here, this is basically like frames and cast actions. This is like the newest cool fun stuff. Most of you heard about frames or whatever and have built frames. Most of you haven't even built something like Supercast or other Farcaster clients and fun stuff. And all of you know, because that is likely what you use, is Warpcast, right? So everyone knows Warpcast. Nobody actually knows what Warpcast does, how it works, and what actually like Farcaster is. Like this is Farcaster, right? Like Farcaster is just a bunch of servers called hubs, which are similar to a blockchain node, and this is basically where all the social media content lives. So then we're also talking about going on chain, right? And oh, Farcaster is decentralized, and oh, isn't Farcaster somehow on chain? Well, yes, there is Optimism mainnet, and your Farcaster account is created here. So if you're talking about your FID, or you're talking about, oh, well, how low is your FID, whatever, you can actually check on Optimism mainnet. There are transactions for it, and this content, like all your stuff that you do on chain, is also synced with the hubs. So the Farcaster network itself, which is just the hubs, are connected to Optimism mainnet for account registration and signer registration. If you're thinking, okay, what is a signer? A signer is basically just giving somebody permission to write. So if you log in to a web page and Discord, Twitter, whatever, they ask you, oh, should this person be allowed to tweet in your name? This is the same for Farcaster. They're able to cast in your name or do actions in your name. And if you just look at the full thing again, it is really quite big. So if you just go and are like, oh, okay, what do I actually do? Well, start out by looking at the API providers. Like there's Nena and Airstack are the biggest ones. Pinata also now has an offering. If you look at their web pages, you'll basically see that all they do is read and write storage and just be able to give you data. So if you scroll out again, and we're going to basically look at it here, then you'll be able to see, okay, this is where the API providers are, and they have access to some kind of Postgres. This kind of Postgres only has data that are from the hubs. So if you're thinking, okay, this is where all the posts are, and you don't need to like zoom in or see whatever, I'll just basically go through the overview and then we'll zoom in again. You can see, okay, this is where all the posts are. The posts are then synced to some database because it's faster, and then the API providers give it to you. So if you're building, say, like Supercast, which builds on Nena, or other clients, or any app that wants to use Farcaster data, then you're just querying APIs. So it's basically no different to building anything in Web 2. Besides that, below, there is the hubs, and you could basically also run this yourself. And if you're now using frames, then frames are shown in any Farcaster client, which means like Supercast, Readcast, any client that supports frames, and also in Warpcast. And what they do is they go through this connection and go to your custom backend. So if we now zoom in again, you'll be able to see that, okay, you're having a custom backend, and that custom backend hosts your code. And your code lives there and it interacts. So this basically just responds and does whatever you say. Okay, so if you're saying, well, okay, I'm clicking this button and then I will get back a link to the FBI Telegram, easy. Then your server just simply needs to respond and give back a link to the FBI Telegram, and then whoever clicked the link will get a link to the FBI Telegram. Same for the rookies group. But your custom backend can also do more, right? It's just like a button press and you have your custom backend. So your frame or cast action can also interact with other APIs. So it can interact with a blockchain, for example. It could interact with OpenAI. We've seen frames that are basically roast me, for example, that came out of FBI, where I'm here, I'm in my Farcaster client, and all I do is I input a name. That name gets propagated down, right? Here, this like getting all the images, post stuff, and then it's in my backend. Now my backend has the name, for example, Samya. And now I want to roast Samya. Okay, what happens? My little backend here is now calling the OpenAI and is telling OpenAI, please write a little roast about Samya. that information goes back to my backend, and as long as we're responding within 5 seconds, we can just basically return the roast to the clients, and now Warpcast shows the roast. And this is all that happens if you're building frames. Also, so if you're looking at it from a high level perspective again, what we basically just went through is that we are here, we are in Warpcast in our client, and we're sending stuff to our backend, and our backend just responds. So basically, that is all that happened there. And this is the magic. You don't leave your feed. The user basically still stays in their feed. So the user is always here. The user never sees anything else than this. They just have a mobile app installed. But you can do your custom backend, you can do whatever on the back. Also, if you're not building frames, if you're building cast actions, it's exactly the same like for frames. If you're building bots, then you're sitting here. You're sitting at the hub level, or you're sitting at the API provider level. Because the API provider, if you look here, they read and write and organize data from their own Postgres replicator. Postgres replicator is a caching layer for hubs. Okay, so hub data is basically here, and this is where all the posts live. So here, if you're having a cast, for example, and every time FBI is mentioned and you want to reply with a link to the Telegram, then you need a bot that watches everything that goes on here on the hubs. And Warpcast, as you can see, Warpcast also reads and writes from their own Postgres replicator, and the Postgres replicator reads from the protocol and to the protocol, so to the hubs, which means that in the end, everything will be on hubs. So if you then go and have your bot read, oh, there's something new mentioning FBI, or just having the letter F, B, and I as combined as a word, then your bot can simply reply to it and you post that to the hubs. And if we look at it and draw it out again, then what happens is that here we see FBI in a post. So there we see FBI, and then our bot goes, okay, we we put our reply here, and this is our bot. And then from there, this gets synced all the way back up. So this goes up to all the replicators. From the replicators, it goes up to Nena, and it goes up to Warpcast, because they all have this little sync here to get it into their replicators, and then people will see the reply. And people here will also sync and see the reply. And this takes some time. So if you're basically seeing some mismatch between the timing, if you're posting something somewhere, say on Supercast or Nook or another client, and it doesn't show up on Warpcast, this basically delay that is here in purple, like all this is why it takes a while. And this is how it all plays together. So your bot basically posts at a decentralized level at the bottom, and because we're here in red at the bottom, we're basically only here. We're also decentralized because you can run your own hub. So even if Warpcast went down, we're still able to see it on our side with other APIs and other clients, or you can just use hubs directly and you'll always be able to see it. And this is also why you can't be rugged by, say, like Twitter API changing, because you can always run your own hub. So everything that is on a hub will be there. Stuff like channels and other experiments like warps, they're only in the biggest clients. So they're only in Warpcast. So if we just have a look at Warpcast again, then we can see, okay, Warpcast has its own database, and that has the channel data, some analytics, and warps. So you won't have access to that because it's not in the protocol. For links out, since we're already also seeing questions around that. If you go to this little fun web page called dtech.vision, you can basically go and click on the Learn Farcaster, and there you will be able to always see the newest version of that diagram if you want to look at it for yourself. And if you go to docs.farcaster.xyz, you'll always get the full in detailed specification. This may just be a little too much detail, especially if you're starting, and it's not 100% up to date always, but it's a really good tool. And then, for example, we're looking at hubs. So we're asking ourselves what is actually at the protocol. This is also a nice visualization of how a hub actually works. Those apps that receive messages and post messages, this is what we looked at with Naynar API, Postgres Replicator, Warpcast. and all of that. And they read also the contract text on optimism, which is also what we looked at. Then if we're going, okay, how does it actually work? There's some Hubble stuff. What is Hubble? Hubble is actually just the implementation of a hub. So it's the program that you run as a hub. There's also some getting started, whatever. There's HTTP APIs you can look through. You can go, okay, I want to see messages because I want to build a bot. And then you can see all the technical details. If the technical details are a little too much for you and you just want easy guides, like I said, learn Farcaster, for example, with frames, and then you can just easily get set up. The fun thing is you'll be just like in 1 minute you'll have your frame up, and then you can look at your first frame. For architecture, like I said, just go here to the learn, and then you'll basically be able to see the diagram. It's also mostly in all the other ones, but I'll update it. So this is just frames and whatever. When we're starting out in the Farcaster architecture, you'll also always have it. So this is the general diagram. Feel free to look at it. Little tip: if you go to graphic and then open a new tab, you'll see it. You'll be able to zoom in on it in your browser as well. You'll also be able to download it and do whatever. Also, feel free to ping me in the general chat itself. I can't see any questions on it um, in detail, but if you have any questions, feel free to post them now or later in the Q&A. Otherwise, back
Cool.
to Shika.